Sorry about that. Also, just to introduce ourselves, my name's Darren Reed. I'm in the same room as James, so we're just going to share one microphone. We both work for a company called Severn Partnership, a local survey company in Shropshire, and we get involved with all projects across the UK, including heritage work. So this presentation is going to be based on a project we worked on a while back, a heritage project surveying multiple castles in Scotland. So just as a brief introduction, my name's Darren Reed. I'm the Operations Director at Severn Partnership. My colleague's James Pike, who is a Technical Manager at Severn Partnership and looks after our Scan to BIM team, is going to give you a little bit more technical insight into the in-depth technical part of the project that we're going to describe. So a bit about Severn Partnership. We've been running for over 30 years and have established ourselves as one of the leading and reliable companies in the UK, supplying digital survey data. We pride ourselves in innovation and early tech adopters. So we like to keep ahead of the times, making sure that we've got the latest equipment to gather the data as efficiently, as quickly and as safely as possible, and keeping costs down for our clients. So to do this, we've had to sort of adopt to the latest technology and stay ahead of the curve. So that involves laser scanning, photogrammetry, like Adam was describing earlier today, and combining all this information to deliver one model that is usable to the client, and a data set that's actually got the ability to be shared amongst the team, because there are obviously wider designers that are using this information. So the sectors that we work in cover a vast area, from rail guided transport, highways and bridges, aviation, estates and property, which is what this sort of talk falls into, energy and utilities, and environmental. So the rail guided transport is our key work that we get involved with, and this is large scale projects from the Trans-Pennine route upgrade, HS2, Great Western track renewals, high output track renewals that cover the whole of the country. So we get involved for a vast amount of data there, and that is using all this new technology that we're going to be talking about in a different environment. The same goes for highways and bridges, where we've invested in the latest technology, such as the mobile mapping systems that mount to vehicles and can laser scan data at highway speed. Aviation, going into those environments and capturing data as efficiently and quickly as possible. Estates and properties, which is heritage buildings, any structures, any building work that we get involved with. And again, this can be internal building surveys, digital archiving of data and elevations, or it could be factories, leveling floors to make sure that the buildings are safe for stacking of materials and things like that. Energy and utilities, so this is underground services. So we use the latest ground penetrating radar technology to capture any information that's under the ground, tracing in pipes, cables, ductings, anything like that that's buried. And that sort of couples together with our other sectors so we can get a full above and below ground model. And then finally, environmental, which is river surveys for flood risk modelling, hydrographic modelling, and things like that. So if we just go on to the next slide here, the project that we're going to talk about, or James will go into detail on, is a project that we worked for Historic Environment Scotland. And it was surveying multiple castles around Scotland for digital archive of data. So the project specification was very tight for this, and they wanted to try and couple as many technologies together as possible, but maintain the accuracy. That was the key thing for them. They wanted the resolution of the data set to be as high as possible, but they also wanted the data to be as accurate as possible. So the ideal scenario for this would have been to use photogrammetry and get a really high resolution data set, but that wasn't accurate enough for them. They wanted a point-to-point accuracy of less than 2 millimeters, and they wanted a global accuracy of the data set of less than 2 millimeters. So we used various technologies to do this, but the final deliverables were a CAD wireframe and CAD floor plans and elevations. These were the key things that the archive needed so that they could be readily accessed as PDF files or DWGs, DXFs on anybody's computer without needing super power or super processing machines. So we also delivered 3D models and the raw and processed laser scan data, but like Giles said earlier, it's coming to a point as to how usable that information is for every man that's looking at it now working from home. They haven't got big, powerful PCs, so it's a way of sharing that information and making it usable to them. So that's why the other elevations and the CAD drawings were delivered along with the high detail point cloud information. So if we just flick onto the next slide, the sort of technology we used to capture this information, we had to do a full robust control network around the castles that we used as a control base. So to do this, we GPS baselines. This was static GPS. So we were set up over these positions for 4 hours plus. We then came off of this control baseline and traversed a control network in, so densified that GPS network with total station or theodolite as they used to be measurements. So we'd measure angles and distances from the GPS baselines, and this would add additional control that we would then tie the laser scanning data and the photogrammetry to. So the control would have been traversed to give us a high accuracy XY position, and then we added level information using a digital level. So this is getting sub-millimeter levels for each of the control points. And then we use that control network to adjust our laser scanning data to. Finally, the areas that we couldn't access by any means without scaffold, which wasn't an option for these projects because some of the castles were very remote. The only missing piece of that puzzle was the tops of the walls that we had to use photogrammetry for. So the photogrammetry in this part of the project was used to infill the top of the walls and tie down to the static point cloud that was already registered to the laser scanning data. So I will pass you on now to my colleague James, who can go into a bit more detail on exactly how we did it, show you some of the outputs, and yeah, I'll pass you over.
Hi all, as Darren said, I'm Scan to BIM manager at the Severn Partnership, technical manager as well. My background, about 15 years experience in the company. Worked my way up from assistant, became a project manager, decided that I want to deal with something a bit more technical because I've got a technically minded brain. I thought this was a bit of a challenge to kind of get new workflows, find new softwares, and kind of see where the market's going with innovation. So due to the scope of the Scottish Castles project being a primary digital archive of the assets, we're expected to deliver a point cloud with a survey point every 2 millimeters, like Darren stated, covering the entire building. In addition to the point cloud, the client wanted a traditional CAD deliverable. So even if we're giving them the point cloud data, the old deliverables that we used to give the client were CAD, and obviously that hasn't changed, and it may do in the future, which I'll talk to momentarily. So why are point clouds becoming the best practice methodology? Well, they're a non-selective and non-intrusive survey method, meaning they collect all visible data on site, which means you don't have to touch anything as well. You're using traditional technologies such as total station, so that would be a surveyor sitting on site for days at a time, taking individual points on brickwork, windows, or any relevant detail, would take huge timescales to complete. Also, there's traditional surveys are subject to human error, missing data. You know, it's nothing worse than getting back from site where it's 6 hours away and realizing you haven't picked up some data. You've got to go back, and basically, potential site visits as a result. So using the non-selective survey method enables us to extract any additional information from the safety of the office. So essentially, we have all the point cloud data there. It's non-selective. It's surveyed everything, and we have all the data in the office, and it reduces the need for a site revisit substantially. Obviously, the huge data coverage is much faster method of survey in comparison to traditional survey methods, making the methodology much more economical and safe. So what is point cloud data? So point cloud data is known as non-intelligent, spatially positioned points within a model space, often colorized to resemble real-world assets and real-world scale. The technologies listed before enable us to collect huge volumes of unstructured data by covering the large areas in relatively short periods of time. We use these in a variety of different sectors, but for the ones pertaining to this presentation, usually heritage properties, castles, and estates and property. There is a number of technologies not listed in this presentation to collect data of highways and railway infrastructure, which are equally interesting. So here's a video we've generated of a point cloud, so a final deliverable to the client, which shows the wealth of coverage that point clouds provide. As you can see, the point cloud data is an RGB format, which means the images taken from the scanner are imposed into the point cloud, creating a realistic representation of real-world assets in a digital environment. The good thing about this data is it can be sliced to see any detail within, and the visibility, within the visibility of the point cloud data set. So UAV. So why UAV? UAV survey was chosen during the Scotland Castle, as Darren stated before, as a suitable methodology for the following reasons. There were a lot of high semi-derelict walkways that proved inaccessible. Areas such as roofs were deemed not safe in accordance with our risk assessments. So the UAV survey was deemed as a suitable solution. This also provided a cost-effective way of surveying the required area and the safety of the ground, covering the entire site extent, including the areas of difficult access. The other benefits of using a UAV is its increased image resolution. So point clouds are great for accuracy, but sometimes they lack the color gamuts. So they're accurate, but they may not necessarily look realistic when you zoom in. So if we combine them with the UAV, you have the best of both worlds. So you have the high resolution, high color gamut, and the accuracy of the point cloud. One of the drawbacks to, say, using UAV technology alone is we would not pass the client's accuracy requirements. So therefore, combining the two was a great solution for us. And at the end of this, it made it to see a very, very pleasing data set. So on to CAD Extraction. So we usually do CAD Extraction in survey softwares, CAD software such as AutoCAD, MicroStation, there's various other ones. Basically, we import the data, we slice it, we create a UCS, which is an orientation, a slice of data, in which we can trace 3D wireframe information out of. Basically, it enables us to extract a very high level of detail that would otherwise be uneconomical. As you can imagine, someone on site surveying these points, you're there for weeks, and obviously it'd be very difficult to piece together what exactly is there. It's also enabled us to accurately assure the quality of our data and the accuracy and quality before we deliver to the client. So essentially, you can perform your own QA checks. The data's there. It's easy to see. It's easy to see if something's missing. It just ensures quality. Like Darren said before as well, we deliver point cloud data to the client, which enabled them to assess anything in the future. And often the client will come back and say, look, this wasn't in the original specification. Can you get this data out? And we can do it for an additional cost. The data's in the office already. We've got it. It's fairly quick and cheap to extract the required data for them, which keeps them happy. So other uses for the point cloud data. So in addition to the benefits of deliverables listed above, we've worked on a number of heritage projects where the point cloud technology was used to assess any subsidence and movement structures. So as you can see in the image, basically creates a heat map of relative movement. So we would go to sites, a set periods, maybe 6 months apart. We do survey with point cloud technology from the pre-existing points. And obviously, because of the accuracy of the point cloud data, when we compare them, we can see differences in the two data sets. And there's specialist softwares out there that create heat maps. So, where the blue would be more and the green would be less. So it's easy to be visualized for the clients and ourselves that obviously there may be some structural issues or subsidence. And, we pass that on to the relevant parties. So one of the newest technologies that's come out, software, is the meshing technology. We've just purchased about £25,000 worth of meshing technology software, which basically, as I said before, point clouds are unintelligent points at intervals in space. They don't mean anything, they colorize, and we usually use them to interpret or trace or 3D model over. With mesh software, you can essentially turn those points into a mesh surface. So essentially, it creates a 3D poly model. Obviously, the issues that we have with this, because it's quite new, is it meshes it. It depends on the quality and intensity of the mesh that you want, but it's a huge poly model. So it's very difficult to optimize. So it's something we're working on currently. But in short, it can turn it from unintelligent point cloud data to meshes, which can be used in polymodel, 3D modeling, and it will be of benefit in the future. So, any questions?
Yeah. I don't know whether you want to wait for questions till the end, Giles, if same as the rest.
If that's all right, thanks very much, Darren and James. That was really interesting. Like, sort of taking us into some definitely territory that is brand new technology to me. But I think we'll come back to it if that's all right by